Good morning, guys. How are you? Today we're going to go ahead and move on with our next lesson for math. Today is the beautiful day of April the 20th of 2020. Our title for this lesson is a familiar topic for you all. We're just going to elaborate a little bit more. It's called line symmetry. Okay? And our objective for today is as follows. Teaks, our objective, Teaks 4.6b, identify and draw one or more lines of symmetry if they exist. For a two-dimensional figure. Okay, so objective Teaks 4.6b, identify and draw one or more lines of symmetry if they exist for a two-dimensional figure. So here we want to go ahead and focus on that objective. We're going to look at our verb, which is identify. We're going to make sure that we can identify and draw. So we're going to do two actions today, identify and draw the lines of symmetry for a two-dimensional figure. Okay, those are our key points for this lesson today. Okay, we're going to go ahead and continue with our language of the discipline for this lesson. Our first one is symmetric. This is a figure that can be folded on a line to form two halves that fit exactly on top of each other. Okay, so a figure will be symmetric if you can fold it in half and exactly it gives you the same example. So if we take this square, for example, and if I were to fold it on the diagonal version once and exactly covers the other half exactly the same, then that figure is symmetric. So this square is symmetric. So if I were to open it up again and I were to try the other diagonal side and the halves land on top of each other exactly the same, it's like a mirror, exactly the same, then that would be a symmetric shape. For this square, we can also fold it in halves horizontally, and it still lands on top of each other exactly the same. How about vertically? Well, this square still lands on top of each other exactly the same, so the shape of a square is a symmetric shape. A figure that can be folded on a line to form two halves that fit exactly on top of each other. Okay, so the square can be a symmetric shape. Now, if we move on, we have line of symmetry. line of symmetry. This is the fold line in a symmetric figure. So, on the square that we were talking about recently, if I were to fold it in half vertically, then this fold, this right here, this line that made the fold, that's the fold line, right? That's my fold line right here. Then when I open it, this line that formed right here vertically, that is what we call a line of symmetry. Okay? It's that fold that we had. Of course, if we folded it diagonally, this way right here, then this square has another line of symmetry right there. The other diagonal way, that forms another line of symmetry. The horizontal folded way, that gives us another line of symmetry. Notice that every time that I'm finding new lines of symmetry, I'm opening the shape up again. I'm not leaving it closed. So for example, that's vertically, we found one. So I opened the shape and we found one line of symmetry. If we do it diagonal one way, I open it up and then there's my line of symmetry. I have to open the shape every time to find a new line of symmetry, okay? That's a big hint. You cannot just leave the figure closed and then try to find another line of symmetry. No, you have to open the shape up again in order to find another line of symmetry. We have to go back to the original shape to find a line of symmetry. A square is not the only one that has lines that can be symmetric. For example, we can take into consideration this rectangle that I have right here. Okay? This rectangle right here can also be a symmetric shape. Okay? If we look at it, can I fold this rectangle one way so I can find exactly the half of it? Well, if we fold it vertically, just like so, right? Do each part land on top of each other? Yes, they do, right? They land on top of each other exactly the same. So this fold right here that we're making right now is the fold line. So when I open it up, I know that this line is a line of symmetry. So I have one line of symmetry right there. Can I fold it any other way? Well, how about horizontal? Right? I can fold it horizontal. Notice I opened the shape. I went back to my original shape. Okay, you can make these shapes at home if you have an extra sheet of paper. Just make shapes and practice your line of symmetry just like I'm doing. So I made a fold right there. The pieces land exactly on top of each other. So when I open it, then this line that formed is a line of symmetry. Good job. Now, can I do this diagonal? Let's try it. Well, I folded it diagonal, but did it land exactly on top of each other? No. As you can tell, we have spaces on each side that do not land on top of each other. It doesn't give me the exact shape, right? So this line that formed, we cannot not consider that a line of symmetry. Even if we do it the other diagonal way, they need to land perfectly on top of each other. You still see that empty space over here. So that means that the rectangle cannot have diagonal lines of symmetry because they do not form the same line of symmetry, such as the vertical fold. You see how they land on top of each other? There's no extra spaces around. And the horizontal fold. Okay? The next shape that we can also work with is a circle. Okay? Circles, lines of symmetry, love circles. Why do you guys think that is? They love circles because a circle can be folded halfways, right? This way. So I can have a line of symmetry there. How about I fold it vertically? That's my fold, exactly on top of each other. When I open it, I have another line of symmetry right there. Awesome. Can we try a diagonal? Let's see. Well, yeah. It gives me on top of each other, right? Exactly the same. That's another one. How about the other way diagonal? Do they land on top of each other exactly the same? Yes, they do, right? Awesome. So there's another line of symmetry. So if you can't notice that I can fold my circle in any way, right? Even I can even move it to you guys as I'm making different folds. Move it a little bit. A circle has constantly a ton lines of symmetry. A circle is infinite in lines of symmetry. Okay? So, lines of symmetry love the circle because it can have a lot of line of symmetries. Okay? So, now let's go over some brief examples. Of shapes, the ones that we previously covered, right? So we look a figure. Remember, I'm going to give you a hint right here. A figure can have multiple lines of symmetry. They can have more than one, okay? So we remembered our rectangle friend, right? We already did it showing you. I showed you together that a rectangle only has two lines of symmetry. We can do it, whoa, we can do it cutting it in half vertically, right? That's one line of symmetry. And we can also do it cutting it the other half horizontally. So this rectangle has two lines of symmetry. Pardon my neighbor, guys. He likes to show off his vehicle. Okay, we also know the circle, right? I'm going to do my best to draw a circle. The circle has multiple lines of symmetry. We can cut it vertically. We get exactly the same thing. When we open the figure up again, we can cut it horizontally. We get exactly the same thing. We can go diagonal both ways and we get exactly the same thing. So a circle has infinite lines of symmetry. Okay, now let's put into effect. How about this one? I'm going to give you this shape because this is a shape, right? I mean, it doesn't have to be one of our regular shapes. Right? So a random shape. Can this one have a line of symmetry? Well, if we were to, let's say we cut it this way, and we were to fold it in half, would they land exactly on top of each other? No. So if we were to fold it in half and bring this part up here, the spaces would not match. So that cannot be a line of symmetry. If we were to do it vertical, would they land on top of each other? Nope. How about diagonal? You can tell already that they will not land on top of each other either way, right? So we can also have shapes that have 0 lines of symmetry. So these first two shapes that I showed you, the rectangle and circle, those are symmetric figures. This one right here, it's just a simple figure and it's not symmetric. Just because you can cut it in half doesn't mean it has a line of symmetry, okay? You have to remember that. They have to land on top of each other. They have to land on top of each other, okay? Okay, so let's go ahead and jump into our guided practice. And in the guided practice, we're going to go ahead and see these two numbers right here. We're going to go ahead and start with number 1 and 2 first. So on here, we want to see if the line that they gave us already, the line that's already there, is that a line asymmetry? So we're simply going to answer yes or no. So are these two lines, is this a line of symmetry or is that line of symmetry? So let's go ahead and take a look. Let me zoom in a little bit so we can see it better. Let's take a look. Is this line, if you were to cut this figure just like it is, in that route, you see it's just cut in half. This seems to be like an empty space right here. So that's empty space. Would that be considered a line of symmetry? So if we're to fold it in half exactly the same, will whatever is shown up here exactly the same down here? No. Why not? Because of this empty space. This empty space should have been popping up right here. Then that would have made it an exactly line of symmetry. But since we don't have this empty space down here, this is not a line of symmetry. Okay? Now, let's go ahead and look at this other figure right here. They gave us exactly one going through half. It cut the picture, the image in half. So if I were to fold this one on top of this one, will we get exactly what's in here? All of this, would it be exactly to this over here? Yes. So if we were to try it, let me move my journal sideways. And if I were to cut it exactly through the middle or fold it exactly through the middle, right? We could be able to see that it shows us the exact same figure. Okay, so this line of symmetry that they gave us, it is a line of symmetry. Okay, so this one was a big no line of symmetry, and this one was a big yes line of symmetry. Okay? Okay, for the following two, for these 2, 3, and 4, I want to go ahead and see how many lines of symmetry each one has. Okay, so we're going to go ahead and do it ourselves. So let's see. Let's start with this one that looks like the letter H. Can I go ahead and cut this letter H into halves like this? Let me cut it halfway horizontally. Will it give me exactly the same what is up here, down here? Yes, so that's one line of symmetry. How about if I cut this figure vertically, going halves this way? Is whatever is on this side exactly whatever is on this side? Yes, so that's 2 lines of symmetry. Can we go ahead and attempt going diagonal? Will it be exactly the same whatever is on this side over here if we fold it in half? No, so no, this diagonal line doesn't work. How about the other way diagonal? Will exactly this line be on top of this? No, so this other line doesn't work. So what it seems, we only have the vertical and the horizontal way. So this one has 2 lines of symmetry. Okay, now let's look at this other figure that looks like a lightning bolt. Now, can we go ahead and cut this one? Right, we go halfways. Will they be able, is this exactly the same as down here? So no, the horizontal way doesn't work. How about the vertical way? I can go up and down. Is this exactly this area? No. Well, let's try going through the lightning bolt, just through this line right here, diagonal, like that. Will it be exactly the same? No, you can tell that this part is bigger than this side. So this line doesn't work. Well, by the looks of it, this figure has none. 0. Nada. No lines of symmetry. Okay? So some shapes will be okay to have a 0 line of symmetry. You will just have to look at the shape, cut it with your pencil, okay? Make sure you're going with your pencil. Remember those hints. Every time that you are opening up a shape, it needs to go back to its original space. Go back to how it looked in order for it to be considered a new line of symmetry. Open it up. That's 1. Open it up. That's 2. we know that the diagonal ones don't land on top of each other, so the diagonal ones are not lines of symmetry. If you need to cut out shapes, just like I did, on a normal sheet of paper, do it to practice. So that way we know what shapes and what shapes are not lines of symmetry. Again, a big hint. I'm going to give you a big hint right here. Hint, 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 because a lot of you guys may get these wrong. This one's going to be hint. Just because a figure can be cut in half, it does not mean it is a symmetric figure. Remember, the pieces need to be exactly the same when folded. They need to land on top of each other equally. Okay, that is going to be our big hint. So, this is our lesson for today. I hope this lesson helps you guys out. And I hope you guys are staying safe. As always, make good choices and see you later on today, guys. Have a great rest of your day. Bye.